Aha, so I knew that was going to happen. I'm back. So the concepts that we're going to talk about today were introduced in last week's session by Erin, and they're going to be revisited throughout the webinar series. If there are any words that you're not familiar with, then just ask a question in the chat and people are online to be able to help you. So you're going to get a chance to be able to learn and interact in future weeks about triggers and impact levels for things like tropical cyclones or heat waves and cold waves. Today is a focus on flooding, which I've complained to Anita is actually a very wide focus because, of course, there's lots of different types of floods. We did get quite a lot of questions in the registration. Some of those were quite advanced, perhaps people looking to apply for PhD studies with me. But this series in particular is for the basics, so more on the beginners to forecasting and those who are involved putting AA into practice. Nevertheless, we will try to answer some of the more tricky questions, either in response to the webinar at the end or maybe bilaterally as well, if you have a particular interest, or of course do want to study for a PhD with me. I'd be happy to hear from you. First of all, we're going to start off. Let me share my screen, see if this works. There. Perfect, there we go. So you should see my screen. So as I mentioned, this is the basics of forecasting floods for anticipatory action, and we are going to cover all types of floods, which you may have seen in Erin's videos. We know that there is a lot, of course, for confusion, so hopefully we're going to try and make clearer some of those more technical aspects that are a bit tricky to understand. Feel free to ask questions at any point in the chat. I've got people online ready to help you, and please make sure that they're working hard. Just in terms of an agenda, we're going to recap on some of those videos with a little bit of an interactive exercise. We're then going to have a dialogue with some scientists who are involved in predicting floods, and then we'll be hearing from practitioners who've been putting that into experience, into practice. So after that, we'll have plenty of opportunity for more questions and answers, and we'll talk about what's next in the series as well. So there were two videos that Erin recorded for you, and hopefully you enjoyed watching them. I did as well. One which is on the different types of flooding, and one which is on the predictability of floods. And so we're just going to recap that a little bit as well. So I'm going to give you some images up next. I would like you to think about what type of flooding it might be an image of, what sort of impacts we might expect from that kind of flooding, and how easy those floods might be to predict. And I'd like you to answer in the chat if you can. So the first image is this one here. I might just be able to share it slightly differently. So there we go. This is an image of flooding. Can
There's
anyone
the questions
give
in the chat, everybody? There you go.
I got it. Thank you, Anita. Yep. Yeah, riverine floods. Excellent, well spotted. So what kind of impacts might we expect from a riverine flood, and how far in advance do you think we might be able to forecast it? And if I move slightly out the way, I think you can see my dog also enjoying this particular riverine flood. A couple of weeks in advance. Actually, that's pretty perfect, because this is the River Thames in the UK, and it goes through Reading, where I'm based. A couple of weeks is probably about right. If the rain is falling upstream in the catchment, we know it takes maybe about a week to get to us at Reading. So that gives us at least a week of lead time just after the rain has fallen. But if we can forecast the heavy rainfall as well, we might have even longer. So yeah, maybe livelihoods, infrastructure. I would say in this case, less likely to be a loss of life because the water is rising quite gradually. So we're not in a sort of situation where people can't move out of harm's way. But of course, we need to make sure that vulnerable people who would need help can be helped as well. So the next photo is this one, very, very different. Bonus points if anyone on the webinar knows where this is. So this is a type of flooding. It's not an earthquake. Yep, so we've got lots of answers saying flash flood. And one person, Michael, is correct in that this is Uganda. So this is in the western part of Uganda, the Nyamwamba River. And it's a flash flood, but also it carries a lot of debris. So you might call it a debris flow as well. So you can see that those houses have been absolutely bombarded. What kind of lead time do you think we might get for this kind of flooding? How far in advance do you think we might be able to predict it? Yeah, so people are saying hours, very short. So obviously we're already seeing the differences between a nice gentle riverine flood and a flash flood or debris flow in a mountainous environment. We've been trying to do forecasts for this river. I think even one day is probably optimistic, and actually the community are using the sound of the roaring of the river to as an early warning of maybe 30 minutes or less at the moment. And it very much depends where the heaviest rain falls within this mountainous catchment. How about this image? What type of flooding is this? Yeah, so we've got some very similar answers there. Pluvial, waterlogging, groundwater. It's kind of a bit of both, right? If the ground is already very wet, then heavy rainfall just forms big puddles on top of the land surface. That's what we would say is pluvial flooding. How far in advance do you think we might be able to forecast this? Yeah, so a bit of a mixture of answers. There's kind of different types of pluvial flooding. In this kind of environment here, if if the ground is already wet, then you probably got an indication that even a bit of rain is going to make matters worse. However, if you were in an urban environment and you were just talking about rapid runoff or something like that, then really you need to know when and where the most intense rain falls, and often that can be very isolated to specific thunderstorms, and sometimes like even in the UK we'd be lucky to get a few hours of warning for urban pluvial flooding. So what about this flood here? Any ideas of the type of flooding here? So we've got dam burst, coastal flooding. Anyone else have any ideas? Great. So a kind of a few different words. This comes back to Erin's categorization issue. You can call it coastal flooding. You could say it's from a storm surge. It's kind of the same thing. So yeah, in this particular photograph, it's a storm surge caused by a tropical cyclone in Bangladesh. Someone has put dam break. Well, in essence, that kind of is also what we're seeing here as well, in that there are coastal defenses that are being breached. Any ideas on the lead time of being able to forecast these kind of storm surges and what the impacts might be as well? Yeah, people are saying a few days. Now, if we know a cyclone is coming, that gives us an indication that a storm surge might be possible. We might also need to know something about tide heights to give us an indication of whether a really severe surge is possible. I think there's a lot of answers of a few days from people who are familiar with Bangladesh. But if you were to take the Philippines as an example, even very slight changes in the track of a storm can change how big the surge would be. So in different parts of the world, there's sort of different abilities to be able to forecast the storm surge. What about this one? I think this photo might be quite familiar to people, so maybe people can guess what flood event this was, but what type of flooding can we see here? Yeah, so Sylvia is correct. This is Cyclone Idai in Mozambique. Someone is saying fluvial. Someone's saying coastal flooding. Yeah, Victoria has the answer that I was looking for. So this is a compound event. In this case, it would have been a mixture of storm surge, river flooding, and heavy rainfall all happening at the same time. So then that becomes much more difficult to predict if we really need that sort of combination, because as well as all of those challenges of predicting the river flood and the cyclone and the storm surge, we're looking for whether the two are going to coincide. So final one here. Anyone have an idea of what this type of flooding might be? Okay, so we've got ice melt, heavy rain, flash flood, glacier. Actually, this was a trick question that I threw in here. So Larissa is kind of right. This is basically management of a river. It's paddy fields and it's not a flood. Or if it is a flood, it's one that's desirable. So I think sometimes it's also worth remembering that for some people, a lot of rainfall can be quite useful, and it's important to think about when something becomes a dangerous flood and when the water is just within what is expected or even hoped for. So I will just summarize that briefly. Do it this way. So we've got lots of different types of flooding. They're all slightly different in the impacts of what might be. So in terms of flash floods, we're usually expecting them to occur in mountainous or steep terrain. It means usually that means that there's fast and dangerous water. The duration is quite short, but it's difficult to predict at the longer lead times. Whereas riverine floods occur when a river escapes its banks. It tends to be a longer duration. It's more predictable in larger rivers, especially those where there's no water management infrastructure. Pluvial flooding is when heavy rainfall can't drain away. So it might be due to waterlogging or in urban environments where there's an impermeable land surface. It's very difficult to predict the precise location it's going to occur at longer lead times. We've got coastal flooding, which is caused by a storm surge. It's caused by the low pressure and intense winds from tropical cyclones, tends to be a shorter duration, but the water velocities can be dangerous, like in the case of Cyclone Haiyan. Especially if an embankment is breached, then that could be even more dangerous. We can predict the heightened risk sometime in advance, but often it's more difficult to predict the exact magnitude, and it's different between different countries. And then, of course, in some cases, we have compound flooding, which is when two or more different types of flooding occur at the same time. So I mentioned that there were a few terms from the last week that we would revisit again. So you might want to note down some of these terms, think about whether you have a good understanding of what they mean or not, and see if you can spot when people say them today. If you want to play bingo, then even better, let us know in the chat when you think you've heard all of these buzzwords. So just a reminder again, from now on, we're going to set the scene a bit with conversations with different scientists, And we're going to then cover putting flood triggers into practice by sharing practitioner experiences. And as I've said already, please ask questions at any time. Actually, if you put them in the Q&A, people can upvote them, and then we can put to our team of scientists and practitioners the most highly rated questions. So I'm going to stop my slideshow there for now, just so I can see the chat a bit better. And we're going to do a bit of a scene setting. So I wanted to see, hopefully Jake is here in the chat, and I wanted to introduce Jacob Levy, who is from MSF. We're working with him quite closely in South Sudan. He is here, so hopefully he can unmute.
Liz?
Yeah.
Liz, just quickly, you've got like you're sharing like a split screen with the one of the
yes,
show and today's, yeah.
Thank you.
Don't share all our secrets of how we run this amazing show.
Perfect. So please do ask any questions in the chat from that initial review of Erin's videos. Jake, it's fantastic. You're on the mic. Can you put your camera on as well? Does that work?
I think it's on. Can you see me?
Permission. Yep. Or maybe I just can't see him.
Others see me okay. I can see myself, so.
Okay, well that's good.
That's the important thing.
There you go. I can see you. Perfect. So the first question that I thought we should all tackle before we start getting into forecasts and triggers is just about how do we know who is actually at risk of flooding? And I know that you've been doing this a bit, Jake, within MSF, so perhaps you could share your experiences on that.
Great, yeah, thanks. So I work for a group at MSF called HACE, which is Humanitarian Action on the Climate and Environment. And we've been doing some capacity building and training around flooding to prepare for floods a bit more systematically. And we've got kind of three main steps to thinking about who would be at risk. So firstly is where. And so we've been reviewing different tools, kind of geospatial tools to look at where in the world geographically floods are most likely to happen and who would be living there. And then you can look at the population in that area. One of the data sets that we've been using is called Fathom, and it looks at the risk of floods in different areas. So yeah, the first step is where. And then the second question we look at is when. So when in the year, like seasonally do these floods occur? And so this might be often just after the rainy season or during the rainy season, and looking at in different places, this high flood risk period will be at different times of the year. And then in terms of the third part is around who, so which communities are kind of the most vulnerable, and doing a vulnerability assessment is really important to see. The same flood might happen in the same area, and you might have two communities, and one of them might be much more vulnerable to the impacts of floods. So, for example, they might be less able to evacuate. There might be more elderly or children or pregnant women who are less mobile. And for example, they might also have higher rates of malnutrition, which might put them at higher risk of flood-related health impacts like waterborne infections or malaria. So yeah, those are the three ways I'd look at who's most likely to be affected by floods. Where are they? When in the year does it happen? And what's their underlying vulnerabilities?
Great, thanks, Jake. And I know we've had a few questions on Indigenous knowledge, and I know that in South Sudan, MSF did some work talking to community elders about flooding. I wonder what you learned from that and how you kind of brought that through into the work that you're doing.
Yeah, so engaging with the communities, learning their adaptation skills and techniques, and also trying best to support them with that is absolutely fundamental to preparing for floods and also responding to them. So in South Sudan, we spoke to a group of elders from the community, particularly agro-pastoralists, so people who had lived in flood-prone regions for many generations, and talked a bit about how when there are severe floods, what kind of things helped the community to know when to move or to collect food in different ways or to protect their houses. And so we learned a bit from this community about how knowing where to go for fishing, knowing when to build dikes around their houses, and all of these kind of adaptation mechanisms, when they're best to be used, but also actually when they're being undermined and when unprecedented floods happen. So when floods that are more severe than have been experienced by them or their or previous generations, then there is these indigenous knowledge mechanisms get undermined, and people who are able to normally cope and survive with certain levels of flooding get pushed into unknown realms and areas where they can't continue to cope and adapt. So yeah, learning from the community and trying to support them with, finding food and protecting their homes and livelihoods is really important.
Great, thanks, Jake. And I know a bit about those Fathom risk maps, and they come with different return periods of flooding. So it's like an outline for different return periods. Is there like which return periods do you use? How do you decide which one to use, or do you look at them all?
I think it's important to know about them all, and in some places to use different ones. But for our global map, we've used a 1 in 100 year return period. So that's a flood that is very severe, but relatively rare. And this is, I think, important to mention based on historical data. So in fact, in some places where climate change or changing rainfall patterns may be increasing the historical, increasing the current risk, compared to historical averages, what was once a 1 in 100 year flood might actually be happening now 1 in 50 years or even 1 in 20 years. So I think it's important to look at the changing trends over recent decades and use the right level of risk in that area, if that makes sense. But yeah, we've been using 1 in 100 return period floods.
Thanks, Jake. And actually, I'm going to segue now to a question for Maureen Ambani from WFP, because we have those risk maps that are showing, as Jake said, a 1 in 100 year flood. But what are flood forecasts predicting exactly? Are they predicting the return period or the water level, or are they predicting something else? So how do you actually set forecast thresholds to maybe link to that risk information?
Mm-hmm. All right. Thanks, Liz, and great to be on the webinar again. Well, Liz, I would say that first of all, you'd have to think about what kind of flooding are you talking about, right? So if it's in the case of a riverine flood, then the flood forecast would be predicting, for example, what's the volume of water that would be going through the river at a particular time. In common terms, people say, what's the discharge in the river? So for example, do we get like 80 cubic meters per second of water going through, say, the Congo River? And would that therefore result in a flood? So the flood forecast would predict a discharge, but then it can also predict the level of water in a river. So for example, it could be, let's say, 7.4 meters of the river level, say in Shebele River. And therefore, you'd know, oh, okay, if that is the level that causes a flood, then that is what you'd get from a flood forecast. But then if you're considering a pluvial flood, then you would be more interested in what's happening with the rainfall. So then you would look to a rainfall forecast that would tell you something that would indicate, especially if the rainfall is going to be heavy enough to cause a flood, or like what you're saying, that maybe it's already been raining and therefore any additional rainfall will actually lead to a flood, right? So you would get information based on what kind of flooding are you looking at. Volume of water, that is the discharge, the river level or water level in a river, or we'll be looking at, for example, heavy rainfall in a particular location or upstream that could lead to increased water flowing through the river. But then for the case of anticipatory action, because people want to take action on on this forecast. They're not just interested in how much water is flowing in the river. They're interested in, is the flow of water gonna cause an outburst that would therefore lead in a flood? So the question then comes, when can we get unusual conditions in like a river or in the rainfall such that we would be concerned about flooding, which is where the question of return period comes in, because you're looking for an event that is unusual in technical terms. Then you start to think about what return period are you talking about? Is it a 5-year return period? Is it a 10-year return period? When you get unusual flow that would lead to flooding. So that information can also be provided in a flood forecast depending on which flood model you're using. So lastly, Liz, on the question on setting thresholds linked to impacts, I think it's similar to what Jacob was already saying. You'd need to have some kind of data or conversations with communities where you want to compare what level of river discharge or river level has been related to historical floods that have led to certain significant impacts on the ground. And it is actually based on such conversations or data analysis that you therefore start to define which particular return periods or which particular levels of the river or rainfall you should now be more concerned about because it is linked to particular impacts. I was going to show something on my screen, but unfortunately, I'm not able to share my screen. But for example, in Somalia, they have this system called Somalia Water and Land Information Management System, short it's called SWALIM, and they did some analysis where they started to define what does moderate risk level or high risk level in the river look like, what does the bank full level of the river look like, and based on this categorization, we then used a flood model to be able to predict the different risk levels, which we then attached to being able to activate anticipatory action in Somalia. Thanks, and back to you, Liz.
Thanks, Maureen. That's great. So I think when it comes to choosing thresholds, on one hand, you've got what caused impacts in the past, and you look at the historical events, and then the return periods can also be useful, especially if you have particular resource availability. So if you're relying on a pot of money that they don't want to release, twice every year, then you need to make sure that you're setting an appropriate return period for how much funding you actually have available. So if you only want to release funding once in every 5 years, then maybe you're looking at a 5-year return period, even if you know that people are more impacted more frequently. I would like to go to Sazad Hussain, who is the director of the Bangladesh Flood Forecasting and Warning Centre. And I think Sazad is online. I'm really keen to hear from you, Sazad, because Bangladesh was one of the sort of first places to have a big implementation of anticipatory action. And I know that the forecasts from FFWC have supported that. So what are your forecasts showing? Are you forecasting water levels, or are you forecasting river flow or return period? What are the forecast models used at FFWC?
Thank you, Liz, for your nice question, also inviting me in this webinar session. Yes, in our center, we basically provide water level forecast. But in association with RIMES, we also try to give what river flow forecast for the Jamuna River and Ganges River.
Interesting. Great. And so you've got two different types of forecasts. I guess they're for different lead times, right? So could you talk us through the different actions that are taken before flooding on the Jamuna River and the different lead times that are needed for those actions?
Okay, for the forecast we are producing in our center, that is, I mentioned, it is water level forecast and it is deterministic, and lead time is up to 5 days. And with the RIMES, we are getting also water level probabilistic forecast up to 10 days. And along with, they are also trying to implement using ECMWF weather forecast to give the 15 days river flow forecast. And different actions, basically, Jamuna is one of the flood prone basin in Bangladesh, and also we have every year floods. So there are different actions can be taken for decision making. Like agriculture is one of the one of the vulnerable for flooding in Bangladesh, and nowadays Jamuna basin we have lot of livestock. So this is also another I mean decision making for flood forecasting. And when we have extreme flooding, then people are basically forced to evacuate and go to the flood shelter. And another application for flood from flood management perspective, like from national level. So before flooding, at least 10 days before, we need to understand whether a flood will be happen or not. Then from our department, and also take care about the embankment management. So then we can also prepare some emergency like collecting geobag or sandbag so that we can maintain the emergency situation during the floods. For instance, 2017 or 16 and also 2020 during the COVID period, we got very, very extreme flood event. So at that time also higher lead time also help us. Also we have also got some, I mean, extended range forecast from the GLOFAS. Still we are also using GLOFAS. So different lead time basically help us in different decision making in Bangladesh.
Great. So I think what I'm hearing is that at those longer lead times, you can take actions that are maybe not such a big issue if you end up acting in vain, sort of more of the preparedness type actions. And then at the shorter lead time, it's things like the evacuation of the community once you've got a bit more certainty in the forecasts. Now, I have a slightly tricky question for you here, because I know that there was some really big flooding in Sylhet in Bangladesh a few years ago.
Yes.
Now, on the Jamuna River, it seemed very smooth how we could set up anticipatory action. Why is it more difficult to forecast the sort of flooding that occurred in Sylhet?
Yeah, thank you. This is basically a tricky question, not on, I mean, also challenging for us. For instance, not only Sylhet, last year we have similar kind of floods in Feni River, Feni Mohori River. So in the southern and southeastern part of the country. Yes, it is really challenge for us because, Sylhet is very located only few kilometers down of Cherrapunji. Cherrapunji, one of the world highest rainfall recipient area. So from as a forecaster, we have anticipated that there may be flood, but the scale of flooding was very difficult for us to anticipate. And the whole, I should say, the whole Sylhet, or at least 80 to 90% was underwater. So this kind of event really challenge for us. We can anticipate, we can just anticipate, but the magnitude of flooding is a bit difficult for us to predict. So in that case, we are also trying nowadays based on the rainfall intensity and historical water level magnitude. We are trying to establish a correlation that if this much rainfall occur, then water level could be this. So it is really challenge for us, and I have mentioned that we have also experienced similar kind of flooding last year in the Feni district.
Yeah. Okay. So you get different types of flooding in Bangladesh. So you've mentioned the riverine flooding, which is kind of easier to predict, the flash flooding, which you're still working on, and then I know that there's also storm surge as well. So you must be very busy at the Flood Forecasting Center.
Yes.
Thanks so much for sharing your experiences. I would like to go to Andrew Krushkovitz now, who works with me at the Climate Center and also IRI Columbia. I know that Andrew has done a lot of work on forecasting flash floods. I was wondering, Andrew, whether you could tell us a bit more about why anticipatory action is more challenging for flash floods and what the solutions might be.
Thank you, Liz. Hi, everybody. I'm assuming everyone could hear me. So I was going to write this earlier, but I'll put it in the chat now, just introducing who I am. And I also included a paper there that we wrote on the different types of flooding, if you're interested. But yeah, so I'm a meteorologist and climate scientist at International Research Institute for Climate and Society here at Columbia University at the Climate School. And yeah, I've been working on flash flood forecasting for almost 15 years now. for the past 10 years, focusing quite a bit on humanitarian and disaster management applications, including working with groups like the Red Cross, Red Crescent Climate Center. But why flash floods? Why are they so hard? Well, they're localized, sudden onset, extreme hydrometeorological events. And we could break each of those words down. Localized, sudden onset, extreme, hydrometeorological. We could even break apart hydrometeorological. These elements all add complexity, both to forecasting floods, but also in understanding risk of flash floods and the different types of impact that they are likely to lead to in different locations. So I broke it down to 3 elements that I think we could talk about here. One is spatial scale. How do we find the appropriate spatial scale to make forecasts of flash floods? Are we trying to forecast each individual flash flood? Well, that's complicated. As many of us know, these sudden onset extreme hydrometeorological events, they could happen on a very small scale. So do we try to forecast every specific flash flood, or are we trying to think more bigger picture? You know, like for example, in the Howrah region of Bangladesh, in Sylhet, like Liz was mentioning, many times flash floods could happen over a much larger scale. There could be multiple flash floods over a large geographic extent. So in that case, are we developing our triggers thinking about almost like an outbreak mentality, like we think about tornado outbreaks and tornadic outbreaks? There's different ways to think about the relevant spatial scales of flash floods, and that's another element that adds to the complexity of when we're trying to develop AA in early warning systems for flash floods. So number 2 is flash floods could occur almost anywhere. This is a question that my lab we think a lot about. What is a location on Earth that has 0 risk of flash floods? Well, we could think of a couple, I'm sure, but there are many locations globally that are at non-zero risk of flash floods. Even if the risk is low, many times the risk is still there for flash floods. And then 3, occurring in areas that haven't seen them before. This is something we're hearing more and more. The narrative of, you know, we had other types of floods occur. When we think of flood, we used to think about riverine flood. We used to think about coastal flood. Those types of floods is what flood meant to us. We're seeing that change. The definition of flood is evolving. And in many times we're seeing areas that haven't really experienced flash floods, and particularly haven't experienced damaging flash floods. Now, this is a type of risk that must be integrated when we're thinking about what types of floods can potentially occur and what types of floods can potentially lead to impact. And then subsequently, what types of floods are leading to the greatest disproportionate impact across different demographic and socioeconomic groups, which is another important fact and another complexity, because many times we're seeing flash floods in urban areas where we have these tight gradients of socioeconomic conditions. So what can we do? Instead of Andrew, talking about all the challenges of flash floods, what can we do? Well, one aspect that we're calling for, I'll actually be at the Global Platform of Disaster Risk Reduction next week, talking specifically about this point. We need greater and more detailed disaggregation of flood type when we're documenting what types of floods have occurred. This is important for us in terms of just assigning impact to different types of floods, but also in terms of developing our modeling architecture. Now there's a big push for artificial intelligence and machine learning driven models, and there are some contexts where these types of models are very appropriate, but still they must be fed data. We must train those models using historical data. And if we are not appropriately disaggregating by flood type, there is an increased risk of miss or underestimating risk of certain types of floods. And I argue flash floods are a type of flood that there is a higher risk of miss and underestimating the risk of. What else can we do? We could talk about floods. We could talk about what types of floods occur in an area. I was very glad to hear discussions around talking to the communities, talking to people who understand what flood means to them. This is critical when we're developing early warning systems and anticipatory action systems. Sometimes floods mean different things. Sometimes the models tell us what flood means to an area, and then we go and we talk, and then we learn that it's not the case necessarily at all. So we must talk about floods, normalize breaking it down further. I mean, you could see a lot of us here, we think about floods, we research floods all the time, but I argue that this needs to be a more accessible discussion, when we're talking about climate risk and extreme weather event risk. And then thirdly, work with the National Hydrometeorological Services in your country. It's a group of people that certainly will be thinking about different subtypes of floods and will have a lot to say about flash flood risk. Now, there still might be questions about the predictability of flash floods, but it's a good way to open up the discussion of early warning systems for flash floods, early warning systems for different types of flash floods, and asking questions related to of the anticipatory action systems, early warning systems, and forecasts for flood, which types are these systems more or less appropriate to forecast? And many times we might find that the flood early warning system, for example, is not useful, and it could be inappropriate to say anything about flash floods. So understanding the limitations of the flood modeling, and for example, does it cover flash floods or any flood type? This is a great way to start a discussion with the National Hydrometeorological Services, where
Thanks,
you're
Andrew.
working. Yeah,
that's great. And someone has already put a question in the chat about when you're going to be speaking at the global platform next week. So there you go. And so we've heard that the flash floods are much more localized. We don't necessarily have good data, and we should talk to the hydromet services. So a lot of recommendations there for us as well. And I guess what you were also saying was that AI might become useful, but it's no quick win on these things because it's only as good as the data that you put into it.
Yes.
I'm going to come back now to sharing some flood trigger examples. So I know that last week Erin shared with you some guidance on what a trigger statement might look like for anticipatory action, and I wanted to make some that are more specific for flooding. So hopefully you'll see some of these things that were reflected in the conversation. So you might have something like a hydromet service forecasting exceptional rainfall. That's something that ICPAC forecasts in East Africa. You would need to have the lead time in there and the location. You might have a forecasting system like the Global Flood Awareness System or even the Google Flood Hub forecasts. You need to put your threshold in there, which might relate more to the return period, and it would need a probability in there as well. Or you might be reliant on a quantity of rainfall if you know that amount of rainfall leads to flooding in your location. So that's just some idea of the flood. It's kind of easy to write these flood trigger statements without actually thinking about how complex it is in practice. So I just wanted to share with you that I do understand this. So I went to Peru 10 years ago when we were trying to write these triggers for flooding caused by El Nino in the north of the country. And it gets really complicated when you think about the actions that you need to take and the lead times that you need to take those actions in, and what the skill of the forecast is and whether it really matches up. And I remember Matthew here on the left negotiating with me. He said, how far in advance can you forecast this flood? I said, well, maybe 1 week. And he was saying, could you give me 2 weeks? And so I had to say, well, actually forecast skill doesn't really work like that when we can't really improve things that drastically. And we had to rule out some actions that he really wanted to take just because we didn't have the lead time for it. We're going to hear now from a few more practitioners in their experiences. I know that things have changed since I've been in Peru 10 years ago, but I know that there's also lots of things that we still need to learn, and hopefully those people can share on the call now. But have in the back of your mind, and I'm going to help you win bingo now, think about hits, misses, false alarms. We know that a flood forecast doesn't have perfect skill, especially at the longer lead times. So what might you do if the flood is forecasted later than you hoped? So you don't have a forecast at 7 days lead time, but you get one at 3 days lead time. Or what happens if at a shorter lead time, the forecast, which originally said there would be a massive flood, is no longer saying it will be a massive flood anymore? And these are some of the questions that the practitioners have to think through when implementing anticipatory action. So I'm going to stop sharing.
Okay, so I think Liz has frozen somewhere in Reading. So I just want to, right, we have 3 or 4 practitioners in the call, but we're running a bit behind time. So I'm just going to jump straight ahead to somebody who hasn't spoken yet. I'm going to jump ahead to Abhishek. Are you with us from the Bangladesh Red Crescent
Anita.
Society? Ah, wonderful. Thank you so much for joining us today. I just want to ask you if you could answer very briefly, why is it important, or how is it important? How important is it to have a pre-activation or readiness trigger?
Right.
Practically.
Thank you, Anita. For the election protocol activation, we do have a pre-activation trigger, and the pre-activation trigger actually gave us time to get prepared with our resources, both the human and the other resources, and implement the early actions more appropriately in the most probable the risk communities. During that time, we do deployed our volunteers to collect household level data to identify the beneficiaries who are likely to be impacted by the flood. And obviously, this is for the cash grant support. And this time also helps us to get prepared or arrange the logistics and identify the places where to disseminate the flood early warning messages and where there is requirement for evacuation support. Yeah.
Wonderful. That's super, super interesting. And I know, for example, in the past, when you've gone out following a pre-activation trigger, as some people call it, I think in the UN, they often use the term readiness trigger. It means the same thing. It's a point at which there's a less accurate forecast, but it helps you to get ready. I know, for example, in the past, you've gone out and taken a look, and there's been something there blocking the river, or the situation's changed, or, so it really just gives you that time to kind of get ready for last minute events. Thank you so much, Abhishek. I'd be really happy if you wanted to share your contact details or any links to any resources so people can take a look at the work that's being done there in Bangladesh. Thank you so much.
Thank you.
We also have Chance from the Malawi Red Cross in the call. Chance, are you with us?
I'm here.
Hi, Chance.
And,
so zooming now over to Malawi. So Chance, just quickly in a couple of minutes, can you hear that storm? We've got a huge storm outside here. So tell us, what challenges have you found in deciding on a flood trigger in Malawi, and how have you overcome them?
In deciding the flood triggers, I think there have been numerous types of challenges that we have encountered. We have issues on limited hydrological as well as meteorological data, which is very limited in terms of spatial coverage as well as real-time availability. So to combat that, what we have done is to digitize data, which at least have been missing for some years without being collected. We have also been doing some kind of modeling and backtesting from various practitioners like the 510, Royal Asconi, and many other agencies that are well connected to that. We also have some issues related to coordination, especially among agencies. We find that in some context, in a specific area, I've got agencies that have got maybe different data thresholds that maybe they use to trigger out and combat that. At the moment, we have what we call the anticipatory action roadmap, where one of the pillars is to harmonize. So we have an agency like our climate change meteorological services are harmonizing all the data so that at least they come up with some kind of harmonized triggers. The other areas on the geographical variability, especially in flood risk areas. So Malawi has got very diverse flood risk areas, and for triggers, not one size fits all. So I've just been trying as much as possible to come up with some kind of regional defined trigger thresholds. And lastly, so on the issues of capacity, most of the communities out there, they still have the lack of capacity in terms of monitoring and using that trigger on the technical triggers that have been issued. So do that, I think I've just been trying to enhance capacity so that people understand, especially in the communities, and take action based on the predicted forecasts and the expected impacts. Thank you.
Thanks so much, Chance. And I think also if anybody's interested as well to find out more, we're going to paste a link in the chat to the recent activation in Malawi, which is very interesting, using an echo crisis modifier, I believe. And also Chance has some really interesting work working at community level, giving small grants to community-based organizations to prepare in advance for some of these like predictable events. So Chance, thank you so much for joining us, and we'll share more info in the chat about your work. Really appreciate it. Have a great rest of the day. And we're whizzing back over. I think we still lost Liz, haven't we? Is Liz back yet?
I'm here, but you don't,
she's here.
You don't have my video anymore. I don't think we managed to predict the Teams crashing as soon as I tried to stop sharing my screen. So I don't have a camera, but I have a mic. And I'm in the web browser, so I don't think I can share my screen. Everything would really go wrong. But what I was saying to myself, unfortunately, because you didn't hear me, was that we would go to Maureen with questions, and that we've heard that at longer lead times, there is less skill in the forecast and more uncertainty. So what does that mean for anticipatory action?
Okay, thanks, Liz. Maybe we need to get better at predicting Teams crashes. But in this case, talking about skill and lead time, for an AA practitioner, what this means is that you need to have an understanding of the balance between lead time and skill offered by the forecast, as well as how much time you realistically need to be able to implement different anticipatory action. Essentially, you need to understand what's the window of opportunity that you have based on the forecast lead time and how good the forecast is at that particular lead time. So for example, in Somalia, WFP was using the geospatial streamflow forecast model that is operated by IGAD at regional level, which can generate a forecast of up to 15 days ahead. But then when they did the skill analysis, there was consideration about we want the forecast to have as low false alarm ratios as we could, keeping it as low as less than 40%, but also to have high hit rates, which they were looking at least 60% or above at the different lead times. And because of that, they ended up setting, that is a country office together with IGAD, ended up setting a 10-day lead time, because 15-day lead time was really giving high false alarm ratios and low hit rates. So the lead time for readiness ended up being set at 10 days, and the activation lead time ended up being set at 18 days. It then means that WFP Somalia, the window of opportunity they had was maximum of 10 days. And so they had to make decisions about what kinds of actions can they realistically implement on the ground with a lead time of 10 days, but also leaving enough time for people to actually do something with the assistance provided. So for example, if they're getting cash transfers, it doesn't make sense to give them cash transfers one day before the flood. You need at least maybe 3 days before the flood so that they can do something meaningful with that cash transfers. And so some decisions were made, like for example, last year, they only decided to distribute cash and disseminate early warning information, and they dropped distribution of nutrition commodities because then they realized that that cannot be completed in the 10-day window period that they had. Thanks, Liz.
Thanks so much, Maureen. And Teams has finally released my camera, so you can see me again as well. Next, we would like to go to Abir, who is from Give Directly in Bangladesh. Perhaps, Abir, you could talk us through what your trigger is in Bangladesh and the actions that you're taking as well.
Sure. Thanks a lot, Liz. Just for context, Give Directly is an organization that does unconditional transfers. Unconditional cash is pretty much the only thing we do. Right now, we're doing a randomized control trial with the University of Oxford and Brack University, where we're trying to assess the impact of cash pre and post flood. And then as part of this project, we've been working closely with FFWC, and without repeating a lot of the things that have already been said by the two speakers from Bangladesh, what we're doing here is taking a layered approach where we are combining FFWC's river gauge data with Google's Flood Hub data, and Google is one of the funders on this project. along with on-the-ground validation to come up with a model that that sort of does not mean that we just solely rely on triggers, but incorporates that on-the-ground field validation by our field teams who go out and speak to field communities and government officials to help us reach a decision point right before we activate the triggers.
Thank you so much for sharing. That's it's fascinating to hear a different experience, and I think the randomized controlled trial will be super interesting for the anticipation community. That's great. Okay, so I think we're coming to the end of the sort of first bit of the session, which is a bit more structured. Michael is going to share some final slides for Anita to speak to. And we'll begin answering some questions, and people are going to throw some questions to us in the room as well to answer live. Yeah, Michael, over to you and Anita.
Can you see the slides right now?
Yes, we can.
Slowly.
Great.
Does everybody else see the Malawi Red Cross?
Yeah, I think it's an animated slide, so you just need to click through.
Keep pressing.
Yeah.
Click through. I just wanted to show you that this here, just before Liz crashed and burned from the call, we'll share this whole slide deck afterwards, and we'll also make sure we address all the questions in the Q&A and in the chat and send it to you in a Word document after the call. So if you just want to just go to the next slide, thanks, Michael. So I just wanted to quickly give you a little bit of a, sorry, and again. So I just wanted to very, very quickly let you know about a really useful resource. I mentioned last week the Global Overview report from 2023 and sent the links, and we'll share them again. So this is very useful because in that report and with the links that come with it, you can sort by country, by hazard, and you can look through, if you could go back one slide, thanks, Michael. You can sort through and you can sort through countries, hazards, agencies, and you can kind of find out what's going on all over the world in terms of anticipatory action frameworks that have been activated, are being developed, and are already in place. So there is a launch of the new Global Overview report, which includes all of this data, latest trends, latest evidence on Thursday, June the 12th, and we'll share the link to that event to you. I also just wanted to flag a recent community conversation that you can watch on YouTube, which was really, really, really interesting there with colleagues from the Climate Centre on the Hydromet and the AA system. We'll also send the link to that for you. And just to tease you into joining us for the launch event, and looking into that 2024 Global Overview report. The next slide, Michael, now is an overview of the kind of data that you'll find in that report. So for example, you'll find, what active frameworks were there in 2024, and you can see here that there were more drought frameworks. That's the sort of little symbol at the top, and then after that, the following frameworks are by flood. So drought and flood are very, very popular hazards to work on for anticipatory action. And then the next slide, you will find all the data which you can sort according to the different flood types. And like this slide is an overview of all the countries that activated in 2024 for these different flood types and when they activated and which agencies, which actions, and so on. So hopefully that's useful for you. That should arrive in your inboxes after the call. I think that is all I wanted to say. Yes, that's all I wanted to say for now. So back over to you, Liz.
Yeah, thank you very much, Anita. I'm starting to read through the questions that are in the Q&A, which is let me see. I think one of them that I'm really interested in is kind of around the good examples or use cases where Indigenous knowledge was effectively integrated with technical or official forecasts. And there's a sort of recognition that there are sort of two different formal systems. I know Dorothy is on the call and has done some work on community-based early warning systems before. I wonder, Dorothy, whether you could speak to this question.
me? Sorry.
Yeah.
Seems to be working. Hi, everyone. Hi, nice to see you. Nice to see some familiar faces. I'm Dorothy. I work with Liz at the Climate Center. And also really excited to see that question in the chat. So we've done, a couple of years ago, we did a piece of work with IFRC looking at how community early warning systems connect with anticipatory action systems. And one of the big, I think, conclusions, at least in my mind, on that piece was that we tend to build these anticipatory action systems at national level, at least within the Red Cross, or at kind of relatively larger district or provincial level. In parallel, though, humanitarians have been working on community early warning systems for ages. And so we have a lot of systems that exist even just within the same organizations that are actually sometimes acting in parallel and then can be connected really well. So that was one of the big, I guess, conclusions of that piece. And then the further along that chain is knowing that these community-based early warning systems have existed in communities for generations, for centuries. Flood ones are a really good example. One community contacts another telling them that the water levels are high and so on and so forth down a river. And so I think there's a lot of work that can and has been done in terms of integrating community early warning systems in national early warning systems work. There's good examples of National Hydromet Services, for example, having databases of community early warning systems across the country. And then those then get connected when there's a national early warning. And this question of like a two-way communication becomes really important. So like the community early warning system, which is a much small scale, it's super localized. Oftentimes it's like very short lead times compared to, you know, something that might be happening at the national level. And so making sure that those two things are connected and that they're speaking to each other can be quite tricky, but has been quite valuable. And so if you can find examples of those within your countries or even within your organizations, you know, if you're working for a national society that has both community early warning systems and an early action protocol, those two, finding ways to connect those two can be really important. So I'll leave it here, Liz, but happy to chat more about this. I think it's a super important question.
Thanks, great, Dorothy. And I think someone else had asked around how you kind of link with the traditional techniques of forecasting floods within a community. And I think that there's that balance perhaps with using the sort of meteorological or the hydrometeorological forecasts at the longer lead times, and then maybe using those sort of traditional techniques. And I have a presentation somewhere that says actually a stick in a river with someone looking at it is a great early warning system. So we shouldn't forget that sometimes the best early warning system is the simplest one that works. So it's important to link with those systems as well, especially for flash floods, for example. I can see that some questions have been answered already about extending beyond meteorological parameters and forecasting impacts. So certainly I know of work where you're essentially forecasting the population that will be directly affected by flooding. We've done that by linking with the Fathom maps that Jacob mentioned earlier. There are also projects beyond flooding, but perhaps bring in the meteorological parameters, for example, to predict dengue cases, also to predict meningitis in West Africa. So there's lots of those kind of models out there. Someone has a question on the triggers of pluvial or flash floods. I know for pluvial floods, there are triggers out there that are in use by Red Cross societies. In East Africa, there's a lot that rely on the ICPAC weekly extreme or the weekly heavy rainfall forecasts. That trigger when there's locations that are at risk of what they call extreme rainfall. In Chad, we're using a product from ECMWF, which is called the Extreme Forecast Index. So there are ways of sort of understanding when a rainfall in the forecast is going to be very extreme. And I think Verena has put a link to the different triggers in the chat. And then I think that there's a question on what metrics do we use to validate a flood forecast model for early warning system purposes, and the accepted proportion between hits, misses, and false alarms. That is a really difficult question. And actually, I don't know whether Sazad is on the call still, but he has written a nice paper on this, if you want to look at an academic article, which talks about how different actions actually have different accepted hits, misses, and false alarms. For example, you don't want to evacuate a community, and 80% of the time that will be a miss because they're going to start getting a bit annoyed with you. sorry, that would be a false alarm. They're going to get annoyed with you and they will stop listening to you in the long run. However, if it's something like pre-positioning stock, then maybe you're happy to have more false alarms because you're prepared to do the actions at the shorter lead time. So I think the answer to what is the accepted proportion really comes down to the actions that you want to be taking. I hope that answers one of those questions. Has anyone else spotted any questions that they would like answering, or whether anyone wants to come on the mic to ask more questions?
I think we can switch off the recording now and have people unmute the mics and ask questions freely as well. So I know it